Good afternoon. I am an educator from Kipler Education, and this is the 7th video of the POTD series that we are continuing. In this series, we are working out the problem of the days for the GFG. The lead code series will be out very soon. Along with that, our system design and OOPS courses will also come out live. So before starting the video, I would wish to remind all of you, all the viewers of this video, about helping us in achieving our target, that is 150 to 200 likes, about more than 100 subscribers, and 300 to 400 views. So before starting off with, okay, so without wasting any more time, let us start off with today's POTD. So today's problem of the day of GFG is count the number of possible triangles. So we will be provided with an integer array error, and we have to find out the number of triangles that can be formed with 3 different array elements as the length of the 3 sides of the triangle. Note, a triangle with 3 given sides is possible if and only if sum of any 2 sides of the triangle is greater than the third side. For example, if your array is 4, 6, 3, 7, and you suppose take up 3 numbers. You have to take up 3 numbers to make a triangle, and only 3 numbers. Suppose you take 4, 3, 7. So you see 4 plus 3 is equal to 7, and it is not greater than 7. It is not greater than 7. So this thing cannot create a valid triangle, cannot form valid triangle. So let us say you take 4, 6, 7. This combination you pick up. Here you can see that. The combination is 4 plus 6. The combination will be, let's say first it will be 4 plus 6, which will be 10, which is greater than 7. 6 plus 7, which will be something that will obviously be greater than 7. And 4 plus 7, sorry, for greater than 6. No, 6, 7 will obviously be greater than 4. And 4 plus 7, which will be something which will obviously be greater than 6. These 3 conditions are satisfied, and therefore this can form valid triangle. Alright, so what is the immediate approach that comes to the mind after getting this particular problem? Let us say your array provided is A, B, C, D, E, F, G, and H. What is the immediate approach that comes to your mind? The immediate approach that comes to your mind is you will take all possible combinations of 3 numbers or 3 distinct indices from the array and see if they can form triangle or not. Therefore, the thing is that the problem boils down to find all possible subsequences of length 3. You have to find out all possible subsequences of length 3. Now, for an array, okay, you have to find out all possible subsequences of length 3. So obviously, you can understand this particular approach will take exponential time. This particular approach will take exponential amount of time. So there is no scope of performing this particular approach. There is no scope of performing this particular approach, as there the time complexity will be extremely high. So this is the brute force. Now the actual algorithm starts from the better solution. See, you have to take up 3 numbers. The first and foremost thing that you do in order to maintain consistency is to sort the array in increasing order. Sort the array in an ascending order of elements, such that when you are at index I, you know that everything on the right of I is greater than I. So if you have to pick up 3 numbers, let's say you have 2 numbers I and J. You have already picked up 2 numbers I and J. The third numbers must be greater than sum of I plus sum of J. The third number K must be greater than sum of I plus sum of J. You can understand very well that sum of I plus sum of J will always lie on the right hand side. So this number K, which is greater than sum of I plus sum of J, must always lie on the right hand side of this particular array. Let the sum is equal to X, this is X, and this is K. This is X and this is K. So K is greater than X. Must always lie on the right hand side. So this approach will be used in better solution. Now, how will it be used in better solution? For example, you first take 2 elements. First, you just simply take 2 elements. How can you take 2 elements? You run a loop from I, from 0 to n. You run a loop from 0 to n minus 1. You run a loop j from I plus 1 to n minus 1. You run a loop from 0 to n first, and then you run a loop from I plus 1 to n minus 1. So you see, you have the array here. If this is I, then j will be this one, then j will move to this one, then j will move to this one, and finally j will move to this position. This is the way j will move. So you see, error of I, the value at I, will always be less than the value which is present at j. So in this way, you can choose I and j indexes. That is error of I. Let's say a and b. B moves here, then B moves here, then B moves here. This way, you can choose the two indexes A and B in a very sorted fashion. Now you see for a fact that A plus B will always be greater than B. So you can understand. This. If it is A, let's say I, and if it is B, let's say J, then A plus B, which is K, must be somewhere around here, X, and this particular K is something which is greater than A plus B. So you can understand that this K, this A comma B comma K, can form a very valid triangle. Now how to get, this is the logic. Now how to get this particular value K? You see for a fact that this is K, this K, this K. If this is the X, let's say you're searching for X equal to A plus B. So if you find the first number, if you find out the first number in array greater than X, that is, you find upper bound of X in the array, then index of upper bound element, let's say it is K, can provide, okay, let's say you find the upper bound of X. I'll explain this particular thing slowly. The upper bound index is, let's say, K. So you see, you are at J. Let's suppose this is K, and let us suppose this is J. Very well. So you see that this value K is containing a value which is greater than X. You are searching for the upper bound of X. Let's say this is I. And this is J, and A plus B, and A plus B equals X, and you are searching for upper bound. It is the first element in the array which is greater than X. And you see that at the index K, this value C is the first element. C is greater than X, which is greater than X. So it is very obvious. That A comma B comma C can form a valid triangle. Now since this particular array is sorted, so you can understand from to the right of C, C1, C2, C3, everything will be greater than C. So C3 greater than C2 greater than C1 greater than C. So you can understand this I and J, this A and B, can form a valid triangle with any of these four. So A comma B comma C1, A comma B comma C, A comma B comma C1, and so on, and A comma B comma C3, all of them are valid triangle. So what is this particular index? Suppose this is 0, 1, 2, 3, 4, 5, 6, 7. It is an 8-length array, and the index value where the higher number, where the upper bound exists, is K, is at index 4. So you can understand it very well that number of elements, or the number of possible triangles with I and J as two sides. What will this value be? This will be the 8 minus 4, which is equals 4. 8 is the length of the array, and 4 is the index. That is, your value will be n minus k. If k is the upper bound value, or the upper bound index, count plus equal to n plus k. Now, how to find this upper bound index? It's very simple. This particular array is sorted. So you can easily apply binary search, where you will search for the first number greater than X. So I will write the upper bound function now. Int upper bound. You have to find out the index. You will be given an array. You will be given an X. Very well. Int low is equal 0. Int high equals n. Int answer equals n. This can be n minus 1. You see now, one important edge case, that if the upper bound doesn't exist, let's say this particular value, at the end, this particular value is X. The first number which is greater than X will occur here. right? And this is at the index 8, which does not exist. So instead of returning 8, you can simply you can return -1 if this particular situation doesn't arise, if this particular situation arises. So there are no element in the array which is greater after j, obviously. After j there is no element. After j there is no element in the array which is greater than x. So you can initialize the answer by -1. So you will say while low is less than equal to high, your mid will be low plus high minus low by 2. Now you will say if error of mid, if it is greater than or equal to, no, you don't have to find equal to, if it is greater than x, then you will say ns equals mid, you will try to come down, high equals mid minus 1, else low equals mid plus 1, and you will finish it and return ns. Along with that, you will now write the main function of the array. So you see, you initialize a count. First you sort the array. Now you take two integers, int I equal to 0, I less than n, I plus plus. You take the second array j, I plus 1, 2n minus 1. The two numbers are taken. So you have to search for, okay, you have to search for index equals error of I plus error of j. You will find out the upper bound in index equals upper bound, the first element, which is greater than this value. And you will simply do if ind not equals -1, count plus equals n minus index. This is the algorithm. Before you obviously you will return, and you will in the end you will return count. Now what will be the time complexity? Very simple. Sorry. Oh, okay. First you're sorting n log n plus O of n square into log n. This is the entire time complexity. This particular thing is going to take off n square. This particular thing will take off n square, and this particular thing will take off log of n. Or if you what will be the obviously it is high is higher order size -1, so it is n minus n. It is n of n. So this is the time complexity, and your space complexity will be of 1. This is the better solution. Now, can you optimize further? You see, it is a sorted array, and you have to find greater than, less than, those things. So if you think carefully, you might come up with an idea to eliminate this log n portion. I do not want this log n portion. I want n square. I do not want a log n portion. So you have to think somehow in a very similar line as this particular algorithm, such that this log n term is efficiently removed. That is, you have to prove this log n term is very unnecessary. So here comes the best solution. You see, if it is there, you are till now you're moving from left to right. You are fixing the first two elements. You are first fixing the first element, then you're fixing the second element, then you're finding how many elements, third elements can occur. Now, if you fix the third element, you are doing it from the first element to third element. Now you will try and do it from third element to first and second element. I just reverse the algorithm. So let us say you try to pick the third element. So let's say this is the third element. So in this range, which is less than k, you will always look, if you will always fix the third element as the best maximum element. Fix the third element as the longest side in the triangle. And you have to find out two numbers a and b from this array such that a plus b is less than k. Is it possible to do this? Actually, it is very simple to do this. You take two indices, I and j. I is starting from 0, j is starting from k minus 1. And you find out error of I plus error of j. You find out error of I plus error of j. If you see that this is less than k, not valid triangle, and you have to increase the sum. Now see, this is a sorted array. So what is the only possible way to increase a plus b? You have to increase a plus b. What is the only possible way to increase a plus b? By decreasing b? No, because this is, let's say, b dash. B dash is less than b. So a plus b dash is less than a plus b. So there is no point in decreasing b. So you have to increase a dash. See, it is a sorted array. So a dash is greater than a. So a dash plus b is greater than a plus b. So yes, you have to increase a. So you have to increment I. So if this situation comes, then what will you do? You will simply do I plus plus and increase sum. But if you see error of I plus error of j. Similarly, if it is equal to, it is still not a valid triangle. So you have to increase the sum. Therefore, increase I, increase pointer I. Now, if it is less than k, valid triangle, valid triangle. This is I, this is j, this is k. 0, 1, 2, 3, 4, 5, 6. You see, this is a valid triangle. Let's say this is a valid triangle, or let us make this is k. This is a valid triangle. So if this is a valid triangle, say A, B, A1, A2, A3, A4. If it is a valid triangle, so how many more? One triangle found. One triangle found. So in total, how many triangles can be found in this way? A plus B is greater than K. You see, A1 plus B is also greater than K, as A1 is greater than A. A2 plus B is greater than A, as A2 is greater than A, and so on till A4 plus B is greater than A. So how many triangles? 1, 2, 3, 4, 5. So 5 possible combinations found. 5 possible combinations found. A, B, C, A1, B, C, A2, B, C, A3, B, C, and A4, B, C. So 5 possible combinations found. How can this be found? You see, J is 5, which is B. A1 is 0, which is the first element. 5 minus 0 plus 5 minus 0 is equals 5. So let us suppose that is A1 plus, now let us suppose that A1 plus K. Okay, one thing. So okay, so yeah, sorry. So one thing, let us say A1 plus K, A1 plus B is less than K, but A2 plus B is greater than K. So how many possible triangles would have been formed? You have to start from A2 instead of A1. So 5 minus 1 is equal to 4. A2 is 1. So 5 minus 1 is equals 4. 1, 2, 3, 4. 4 possible triangles. So you will automatically increment the counter by count equals count plus j minus I. Now you see, if it is K, if it is I, if it is J, and this forms a valid triangle. So anything from I to J till here can become a possible first element. Now from A dash B C can become a possible triangle. Now A dash plus, because A dash plus B is greater than C. Similarly, if it is A double dash, A triple dash, A4 dash, and A5 dash, A5 dash 5 plus B is obviously greater than C. If A dash is greater than B plus B is greater than C, A double dash plus B is greater than C, A dash 3 plus B is greater than C, A dash 4 plus B is greater than C. And since A1 dash 5 is greater than A dash 4, therefore it is also applicable. Now you see A5 dash plus B plus comma B comma C, this can be a valid triangle. Why? Because A dash comma B comma C is a valid triangle. And that is because A5 dash is greater than A dash. Now can you say that A dash, A3 dash and A4 dash and C is a valid triangle? Can you say that A dash, A4 dash and C, is it a valid triangle? Let us see. If I say A dash plus B is greater than C and A4 dash plus A4 dash is greater than A dash, it necessarily means that A4 dash plus B is greater than C. But does it necessarily mean that A dash plus A4 dash will be greater than A plus B? That doesn't necessarily mean, because this is not always true, since A4 dash is less than B, and because of this factor you cannot say this particular thing. This cannot be said. Now staying in this situation, there is no way to identify if this and this is a valid combination. Is this and this is a valid combination or not? If 0, 1, 0, 5 and 7 is a valid combination, there is no way to find out whether 0, 4, 7 is also a valid condition using this condition. No. So there is no way but to fix the two sides of the triangle. K and J. And the only way to find out is the I to J. Every possible valid combination I dash J comma K is a triangle. But it is because I dash plus J is greater than K. But if something goes less than J, let's J dash, it does not mean if I dash plus J dash, I dash plus J dash is greater than K. So in this situation, what will you have to do? You will have to fix J dash, you will have to fix I, and you will again have to start iterating from here to here. From here to here. You will again have to start iterating from here to here and see if I plus J dash plus is greater than K or not. let's say it is I1 plus j dash is greater than k. Why? Because the sum increased, because the sum increased, it might happen I dash plus j is greater than k, but it is also highly possible if I plus j dash is less than k, because I plus j dash, is less than I plus j. That is for sure. That is for sure. So this particular condition that I was saying, a plus 4i 4b 4 dash b, is it greater than a plus b? Not only it cannot be said, it can be by sure, said that this is not greater than b, it is actually less than a plus b. So by this condition, it can be said that it is less than a dash plus b, and a dash plus b must be greater than k. So there is no inequality nature that is coming up. So effectively, you have to reduce j to j dash. You have to reduce j to j dash, that is j minus 1, and you will again have to try from I to j dash, keeping the third side as k, and you have to find out the number of possible triangles. Now suppose suppose this is the first side at 0, this is j at 5. So how many triangles are possible? These three triangles are possible. How to find these three numbers? 5 minus 1, 0, 1, 2, 3, 3. 3 minus 0 is equals 3. There are three triangles possible. So you have to make the counter increase as count plus equals j minus I. So effectively, what will be the code? This is the condition. So if sum is greater than k, obviously you say that this is a possible thing. Count plus equals j minus I, and you will decrease j minus minus. You have to decrease j, and you have to find out I j dash in this range how many triangles are possible with the third side as k. And if it is possible, if it is the triangle formation is not possible, you have to increase I to I dash j, I1 j and k, and see if I1 j and k can form a valid triangle or not. So you have to basically increase the sum. So effectively, what will be the code? The code will be very simple. For I belongs to 0 to n minus 1, for j belongs to I plus 1. Sorry, what am I doing? You have to increase, so how will a code look? You will start your key, if a triangle always has three sides. So at the least possible triangle can be formed in this particular manner, where the triangle with the smallest perimeter is formed. So your k can start from here effectively and move on till the last. So k range is 2 comma n minus 1, and I will be 0 for each k, and j will be k minus 1. This will be the two sides. So the code will be for, so you will first put a counter. First you will definitely sort for k 2 comma n minus 1. What are the two things that we have? We have I equals 0 and j equals n minus 1. While I is less than j, sum equals error of I plus error of j. If sum is greater than k, obviously it will be a valid condition. CNT plus equal to j minus I, and along with that, what will happen? You see, I to j minus 1, j k can be a valid triangle, but I j minus 1 and k, will it be a valid triangle? We have to find out, because I j minus 1 is less than I plus j. So I plus j minus 1 is less than I plus j. So it might happen I plus j minus 1 is less than k. Might happen. So in that situation, you have to start from j minus 1 again. And you have to increment the count as and when required. And if this condition doesn't match, then a valid triangle cannot yet be formed. You have to increment I, you have to increment the value of I, and see if to increase the sum, and see if the sum is greater than k or not, the new sum. At the end, you will return count. This will be the algorithm. So effectively, what will be the time and space complexity? You see, we are having one loop. We are effectively having one loop. So what will be the time and space complexity? This k is moving all throughout. Now for each k, I is moving, j is moving, but are they moving entirely? No, they are not. Are they moving entirely? No, they are not. You see, once they cross each other, or meet each other, they stop. So effectively, if it is k here, they are effectively moving like this. When the k is here, they are effectively moving like this. So effectively, for each k, this is moving k minus 1 number of times. For each k, a movement is occurring for k minus 1 number of times. So the time complexity effectively becomes O of k into k minus 1, which is equal to O of k square. which you can write, which you can generalize in the form of O of n square. And space complex, oh yes, I forgot one thing, the sorting time O of n log n plus O of n square. And the sorting space complexity, it will be O of 1. So now let me show you the code. So sorry, so I have sorted it first. The counter has been initialized. The third side is starting from 2 and will move till the end of the array. I am taking the first two sides and I am trying to find out how many triangles can be formed. So if the sum of I, j and k, if the sum of I and j is greater than k, is greater than the third side, then from I to j minus 1, which is j minus 1, j minus I number of elements can form a valid triangle. And I am decrementing j to restart the algorithm of I and j with a new value of j and find out how many new triangles are possible. With I, j minus 1k, I, j minus 2k, and so on. I'm decreasing the sum. I'm basically decreasing error of I plus error of j. I'm basically decreasing error of I plus error of j and see how many decreased sum is greater than k. I'm again decreasing error of I plus error of j and I'm seeing how many decreased sum is greater than k. And if the sum is less than k, then I'm incrementing the value of I to increase the sum and find out whether the increased sum is greater than k or not. And at the end, I'm returning count. Let's run perfectly. Just submit it. Yes, it is submitted. So as always, this particular code will be provided here. This particular code will be provided here. Also, as always, this entire notebook shall be present in our website. This entire notebook shall be present in our website, kepler22b.vercel.app, https. In the community library resources tag, inside the outside, I mean in the resources tag there is the community library, and the resources is present in the library section of navbar. So this concludes today's POTD. These notes will be updated and hope to see you on in the next video. Thank you.